Hey, good morning and welcome to, I think, the third seminar in our series on data science for society. It's really great to have all of you here. Today, just FYI, is a UP Wellness Day, so I have to, for a lot of us, started immediately after this session. We're not supposed to be using devices, so it's going to be a tough one. But we had scheduled this before, and really, it's great, I think, to start the morning this way, and then look forward to having a more chilled spring kind of period. Today, really happy to have with us Emily Muller, who is a great, has become a great friend and also a collaborator. We met a long time ago before at the African Institute for Mathematical Sciences. And then she came on when I was at the CSR to be kind of a data science intern, and has gone on to do great things. So yeah, as always, we record these. We will start with Emily's talk, and then after that, we will open it up for questions and comments. Just for kind of ground rules with that, Emily will speak. If there's questions, you can either have them with you and then just get ready, or put them in the chat, and later on we'll go through those, and then hopefully Emily will be able to answer them. So yeah, on that note, Emily, you can, I guess, switch on your video and then also say hello and then start sharing your screen.
Hey, so it's saying I cannot start my video because the host has stopped it. So I think maybe you won't be able to see me for a little while.
Oh, let me see. Why can't, okay, let me see. Oh, okay, you start your video.
Okay, awesome.
Cool.
So thank you so much for having me. Thanks for being here. As Mukosi said, we met ages ago at AIMS, and I can see that Yaya's on the call, so I'm super happy to see a familiar face, and Tabang as well. And thanks for having me. It's nice to be able to share what I've been up to since all of the learning that I was able to do at AIMS and at DSFSI. So today I'm going to be talking to you about measuring the urban environment using street view imagery. Can you see this thing at the bottom, or is it just me? Okay, hopefully you can see my slides.
No, we can see your slides completely. We don't see anything else.
Okay, awesome. So I'm in my second year of my PhD. I'm supervised by Majid, Seth, and Emily, and MRC are my funders. I'm going to talk to you about some work from Pathways, and this is just a cool infographic about some of the work that I've been doing. So just a personal introduction. As I said, I'm a PhD student. I'm doing computer vision and urban analytics at Imperial College in the School of Public Health. And I kind of got onto this path previously. I was working as a research assistant in this group, Pathways to Healthy Equitable Cities, which is a multi-institution venture looking at how to measure mostly different health effects in urban environments across the world. So I sort of was involved in these two projects. One is transferability, where we were trying to predict socioeconomic outcomes in cities around the world using street view images, and testing the transferability of images and models from one place to another. And the second project was looking at predicting pollution levels using street view imagery in Accra, Ghana. And then there's my PhD research, which I'm going to jump into now and talk about those two a bit later on, hopefully at the end. And at the moment, I'm actually on a little hiatus from my PhD, working on a 6-month internship at Accenture, looking at synthetic data generation. All right, so let me begin with sort of the research that I'm doing and the motivation. So the question that I'm essentially looking at are, what are the social determinants of health, and can these reliably be encoded with imagery? And this sort of was fueled by work done by Ezra Soul, who's in the Pathways group, where she essentially looked at images in London, street view images taken from Google, and was able to predict different measures of socioeconomic status. For income, for example, she was able to build a model that could predict the decile of income within ±1. So if it was decile 6, her model was actually predicting 5, 6, or 7. This sort of was a template and showing that there was a way of using imagery to understand the city, And sort of the motivation behind this is to say, okay, we've got these census statistics that are happening every 10 years. They're very infrequent and they're very expensive. Is there a way of using imagery at a higher spatial resolution and a higher temporal frequencies to measure and understand cities? Okay, so some of the limitations, she was using an end-to-end model. So there wasn't really an understanding of why certain places were being predicted high or low. And also in addition, the socioeconomic data which she did have is reported at an aggregate level. So in London, we have something called the lower super output areas. I think in South Africa, it would be called enumeration area. And that's taking the average of, let's say, 1,000 homes. So we also don't understand for an individual image, what is the sort of label. So I sort of came at this question by saying, can we create our own label using clustering, so unsupervised learning? So just for a bit of background in terms of London, why is London in particular interesting? Not only because I'm living there, but also because it's very heterogeneous in terms of its makeup. So there's areas of quite high and low income situated right next to one another. And this translates to health if you can see the correlations in the plot, you can see this area, which is South Kensington, which actually is where the Imperial campus is, has a really high life expectancy. So this life expectancy plot on the right is done by Thea Rashid. He's a colleague and friend, and he's built Bayesian models for predicting life expectancy, for modeling life expectancy. And there's quite a lot of similarity between this income and life expectancy and essentially health within the city. And as I was mentioning, you can have areas of high life expectancy situated right next to areas of low life expectancy. So as I mentioned as well, the areas that we get the census statistics are at lower super output areas, which should be equivalent to enumeration area, or maybe an aggregate of that. And these sort of boundaries are drawn somewhat arbitrarily. So this is a boundary taken from Camden. You can see that it's got this gorgeous hotel, which is right on the main road, and right next to it, very, very close, is what we call an estate in the UK. And similarly, on the left-hand side, you've got the LSOA boundary, and either side of the road is being split up, but actually they look really similarly. So another motivation for this research is also to have a look at, what is the meaningful delineation of the city, of a neighborhood, of understanding sort of homogeneous groups within the city. And especially, how can you then target sort of interventions where you might need to work on, what do I want to say? You might need to focus on building up that part of the city. So here are just a few examples of images from London. So you can see the Google Street View images are actually really good in capturing the built environment. And you can see a range of different sort of buildings in this display. So one of the maybe fortunate/unfortunate things is that the Google Street View car has been going around London since 2008. So there are a handful of millions of images of London taken over the years. And underneath, what I've done is I've sampled the roads in London at 20 meters. So in dark green, those are the sampled roads, and in light green are the actual individual unique images. So for 2018, where there's quite a lot, there's almost 1 million, there's 70% coverage of the roads if coverage is every 20 meters. So there's almost some missingness, but there's almost spatial continuity of images within the city. Okay, so back to the question, how to meaningfully extract information from imagery for clustering. So looking a little bit at different methods, I sort of categorized them into either two-step or end-to-end, where two-step is how do you extract, first of all, features from the imagery, and then put it into some clustering algorithm, or end-to-end, is there a way of clustering and feature extraction in the same step? So I ended up using this approach above, but I'm still working on looking at different methods and how they compare. So for k-means clustering, how to choose the optimal k, there's various different sort of statistics which you can look at to optimize or minimize. So in the top, I looked at the silhouette score. I don't actually recall exactly what these are, I'm very sorry, but essentially you're looking at the separability of the extracted features. So I actually didn't mention about this method. So it uses the VGG architecture trained on ImageNet, and as opposed to just taking the final layer of the VGG, it does this thing called region of interest pooling. And after that feeds it through some additional layers. But the idea here is rather than having like a global feature extraction method, it becomes a local feature extraction method because of this region of interest pooling. And at the end, you get a feature, you get a 512 vector, which then is input into clustering. Clustering doesn't deal very well with high dimensions. So we've taken an image which is 640 by 640 down to 512 and then used it for clustering. So eventually the idea with those 512 vectors is to then cluster them into separate groups. So looking at these silhouette scores and David-Baldwin indices is looking at the separability of each clusters, and David-Baldwin is to minimize and silhouette is to maximize. So I ended up looking at two different Ks, which was 20 and 9. And after visual inspection, I settled with 20 clusters being more interesting for the purpose of what I wanted to look at. So this is what 20 clusters look like in the map of London. Colors we don't yet have meanings for what the clusters are, but you can see there is a bit of spatial patterns here around. This is East London here. This is sort of the river that continues, and then in the center, you've got this green cluster, but we'll have a look at each of them. So how do we now interpret what the clusters mean? This is one of the most difficult problems with unsupervised learning. So first of all, I've looked at visual inspection. What do the groups of images look like within each cluster? What is the spatial distribution of the images in London? And also then what are the correlation with features from imagery? Internal, which is sort of image-based, so looking at object detection and segmentation, and external, so external census statistics, for example. And for this, for extracting features from imagery such as objects and segmentation, I use the TensorFlow Deep Lab API, which I'd really recommend. It's really user-friendly. So using the features of segmentation, the portions of segmentation, so that is how much of the image is made up of building, of this gray amount, how much of the image is made up of this tree, which maybe is classified as vegetation, how much of the image is made up of road and sidewalk. I've included those as features for a classification model, and also the object counts in each image. So I've used a random forest to predict the cluster assignment using these proportions, and the accuracy is 0.46, which if you think there's 20 different clusters, for random allocation, it should be only 5%. So accuracy at least is doing way, way better than random. And looking at also the variable importance, it's telling us, okay, well, which features are the most important for predicting each cluster? So building segmentation is high, vegetation segmentation is high, car segmentation, road, and so on and so forth. So using that, I decided to look at the normalized features per cluster and try and come up with some interpretability of each cluster. So for example, down at the bottom, I hope you can see this because I can't see it because of this thing. Oh wait, I can move it. Cool. So down at the bottom for commercial, if you look at the spatial distribution, they're very concentrated within the center of the city, and then sort of follow these arterial, what would be road networks. This is essentially exclusively the only place that includes people. So I've given it ultimately the name commercial. So these sort of names in white is what I've classified each of the clusters to be in terms of meaning. If we look at the second cluster, sort of a little bit distributed in central, but fairly homogeneous over the city. There's a lot of building, but there's also sort of a higher amount of terrain than some of the other clusters, which include buildings. And then I've classified, also looking at the images, I've classified these as high density estates. So typically taking up a lot of the image, quite high-rise buildings, and this estates typically have, you know, grass in front of them and are coming out of this area of grass. In the top cluster, fairly concentrated in, so there's this place here in East London, and not necessarily completely central, but still quite close to the middle of London, with a lot of building taking place. And this is very typical housing of London, I think. It's very homogeneous, like copy, paste, repeat all the way down the road. And this is what we call terraced housing, and it's typically residential housing. Then we've got these three clusters here, which are looking more on the fringe. They all actually look quite similar in terms of spatial layout. What's interesting in these bottom two, if you can see here, the counts of car objects quite similar in each of these images, in each of these clusters, but in the bottom one, there's a lot more segmentation. And it turns out that they both have a lot of cars, but the cluster here is having cars parked further away in the image. So typically they take up less of a proportion of the image. So this might be cars that are parked in the driveway as opposed to cars that are parked on the road. So this is 8 of them. On the next page, there should be different ones. Why am I struggling to change the slide? There we go. And these are less descriptive of the built environment and more descriptive of buildings and more descriptive of roads and vegetation. So at the bottom here, there's this cluster which is sort of more around the outside of London with very, very high proportion of vegetation. And this is...
I'm not sure if you might want to take questions that might be contextual to these current slides. There's 2 questions that came on.
Oh yeah, sure.
Yeah, they're in the chat if you open the chat.
Okay, cool. Let me have a look. Did you label the sum subset to get 40? Did you hand label the sum subset to get 40% accuracy? I didn't hand label any of the clusters. I've used as output the clusters which were assigned from the RMAC and clustering method, and then build the random forest from there. So yeah, as I did mention, that one of the most difficult problems is, the interpretability of unsupervised learning. So in the next section, I'm going to talk a bit more about the difference between sort of this unsupervised approach and understanding the perceptions that people would have of their environment. So, okay, so what is the advantage of using a random forest to predict cluster assignment instead of a deep learning? So I've only got a few features. I used a bunch of different models. I used SVM, I used logistic regression, I used a neural network, not super deep, but this one happened to have the best accuracy. And I think on top of that, it's really useful for actually looking at feature importance, which isn't so interpretable for some of the other methods. Okay, I'll take a look if there's any more questions as they come up. I hope I answered your questions, and if not, then please let me know and I'll try and get to it. Okay, so what was I saying? So we have this high proportion of green here. We can also see that in this cluster, for example, in this cluster, it's actually following a lot this arterial network of roads, which is a bit more descriptive of, as I was saying, of the roads and especially greenery within the roads. So this is currently how I've gone about, and here we have this one with lots and lots of cars. This is currently how I've gone about interpreting the meaning of the clusters, and I still have to do some further work, really getting to a finer, detailed description of clusters. But for now, let's go to the next slide. So here, for example, it's just a look at more of the images and how they differ, because it was difficult to see with just 9. So this is this typical terrace residential that I was speaking about in London. Here is this typical estate with the typical green and high density, quite high rise, very often red brick as well. Next slide. So residential fringe driveway with cars. You can see the cars are sort of perpendicular to the image, whereas this is residential fringe with no cars. One of the difficult things here is these could have just been taken on a day where the cars happen not to be in the driveway, which doesn't necessarily tell you anything interesting about the difference in these clusters. Parked cars in this residential fringe, and then what I've called leafy residential. So this is just a few examples of the clusters so you can see a bit better. High density modern and commercial. So commercial typically on the bottom floor of these buildings, there's just different sorts of activity and also are characterized by a lot of red, typically buses, which are going along some of the main routes in the city. And not all clusters are created equal. So here's just the visual of all of the 20. And this 1, 2, 3, 4, I've classified as image artifacts. So one of the steps that I took with the Google Street View is I wanted to, instead of capturing down the road, I wanted to capture the building facing side of the road. And I sort of had to calculate that using azimuth angles and whatnot, but it wasn't always perfect, whether that's because my calculation wasn't always perfect or whether that's because sometimes the way that the images are stored are imperfect within the Google server. So the clustering actually sieves these out into different cluster, and I've just called these image artifacts because it wasn't necessarily the images that I was interested in looking at. So from 20 clusters, I was able to reduce down to 14, 4 of which were image artifacts and another 2 which I grouped together. So I think if you remember here, I sort of grouped these non-residential roads together and these residential fringe, which sometimes have parked cars and sometimes don't, together. And if you also remember, I said I also did 9. And looking at the 2 that I grouped together, which was 8 and 9, they come from the same cluster if you have fewer. And similarly, 1 and 6, they also come from the same cluster if you have fewer. So this is sort of validation of my own interpretation in a way. And 5 out of the 14 were descriptive of the road, and 9 out of the 14 were descriptive of the built environment. So then the next question that I had was, well, how do these clusters relate to both the census statistics and indicators of pollution? Particularly because I'm funded by the MRC, the Center for Environment and Health, and one of the big themes within the center is pollution, and even in pathways, one of the big themes is pollution. So this previous work, let me move this thing because it always gets in my way. So this is a previous study done in, I think, 2014 by Singleton and Longley at the University of Nottingham. It's called Mapping the Tribes of London. And they actually did something not too dissimilar to what I've done, which is taken output areas. So previously I was talking about lower super output areas, which there are about 5,000 in London. Output areas, there are now about 40,000. So much smaller spatial areas. And they've taken 71 different census statistics from these output areas in London, and they've clustered them, and they've come up with, I don't know how many there are here, but let's just say 15 different classifications for the clusters of output area. And I've only plotted 7 on this map here in the top right, because there's a lot happening, so it's actually difficult to see. So I've just plotted 7 of them, and you can see, for example, the green one is it's quite a lot on the fringe of the city, and similarly with the blue one. So I wanted to say, well, how does that relate to the clusters that I have, and especially the ones about the built environment as opposed to about the road? So for these ones which are on the outskirts, which they've called not quite home counties, so this is like a very English phrase. Home counties are all of the counties outside of London, surrounding London, and they're typically really wealthy. So not quite home counties, it's just still in London, but almost this wealthy fringe. So they're made up a lot of residential fringe, which is not unsurprising, a little bit less so in the detached retirement class, which has now also got leafy residential in it. This sort of lighter green one is very central in the center of London, and it's made up of this commercial cluster and also high density modern, which is sort of different from the blue cluster here, which is called students and minority mix, and Bangladeshi enclaves. So also in the history of London, there's been a lot of migration from different population groups. So for example, there's a specific place called Tower Hamlets, which has got a really high population of Bangladeshis. So there's this very strong pattern of, you know, people, communities which stick together in certain areas. And that's really, it's really, really common. So if you go to certain places in South London, North London, you'll really see like different communities in each of those places. And so for these last 3, students and minority mix, Bangladeshi enclaves, disadvantaged diaspora, there's made up it's quite similar to educational advantage. However, instead of this commercial sector, it's actually a lot more high density estate, which is interesting since they're sort of in a similar spatial area, but the clusters are actually distinguishing between, you know, what is commercial, which might be new builds typically where students are able to, where people are able to afford the premium that comes with them, as opposed to high density estate, which sort of are in a different financial band. Okay, and then for pollution, I've got these Tranquil City Index indicators, which I think was every 100 meters, but I can't remember exactly, but it's done in sort of grids, and it's from a group that are looking at mostly sound, but also just well-being of the environment, putting in multiple different measurements and then coming up with one index. So looking at how these relate to the clusters as well. On the top end of the spectrum, I think this is cut off slightly. On the top end of the spectrum for tranquility is the green roads and the trees and the leafy residential. On the bottom end is this sort of commercial, industrial, and high density modern clusters, which sort of makes sense intuitively. Okay, so kind of how am I taking this work forward? So as I mentioned previously, there's loads of images in London. So I wanted to have a look at, so we had a census in 2011. We also had one this year. So I'm sort of crossing my fingers and hoping that the census data for this year will be released next year. And to be able to then look at, given what the city looked like in 2011, and the images corresponding to the census, and what it looks like in 2021, and the images corresponding to the census. So that's sort of the next step here. And I'm downloading images every month, trying to do little workarounds around the API keys, so it's all free, because otherwise they're really expensive. And okay, so I mentioned previously also this model that I used, and there's sort of, if you add this cluster label loss, you can do it in one step. So this deep cluster model was used by my colleague Barbara for the work that she's doing on satellite images in Accra. So using this model, and then plus on this vertical axis, what if you add a reconstruction loss? So looking at generative models, which I kind of investigated, but it was really not, the performance wasn't that great, but I'm interested in seeing if I can get something working on that front. For deep cluster, I've just done a small comparison, or I should say we've done a small comparison, because Barbara ran these for me on the deep cluster. And what's most interesting here is the deep cluster has this cluster A, which is getting an input from all of the clusters from the RMAP. So I haven't actually figured out what this cluster is and what it means yet. But one of the ways that we were going about comparing was to say, well, let's look at all of the features, such as building segmentation, the ones that I mentioned before, and what are the differences in distributions for each cluster across RMAP and deep cluster. So this plot here shows the sum of the t-score differences, and essentially the lower the t-score difference, the more similar those clusters are. So 6 and 2, I've said, are quite similar, 2 and 0, etc., etc., etc. And if you look at the next plot, so I just mentioned here 6 and 2, I've called it 22 because they have the same name. So deep clusters on the right-hand side, whereas the RMAX on the left-hand side. And just plotting all the distributions of building segmentation, car segmentation, vegetation segmentation, you can see sort of how similar each of the clusters is with respect to the features. So there's some correspondence between each of the methods. However, I think there's still some work to do in understanding what this 8th cluster is and what it's picking up that isn't being picked up, or if it's just picking up noise and sort of creating an extra cluster of, I don't know. So what I'm working on at the moment is trying to look at methodologically, looking at, okay, how are each of these methods resulting in different clusters, and how to really include this interpretability of clustering methods into the pipeline. Okay, so I also said that I was interested then in understanding perceptions of the environment as opposed to unsupervised clustering, where it's really difficult to come up with a label as much as I'm trying. So I got inspired by this work, Place Pulse, which was done in 2000 2014 and 16, where they essentially asked people to rate images. So first of all, it was done in 2014, on a quite small scale. It was then updated in 2016 to scale across the world, essentially. So they had 110,000 images from 162 cities around the world, and they were able to collect 1.1 million comparisons over 3 years on different indicators, so safety, liveliness, beauty, wealth, boring. And here you can see some examples of what was low across the world and what was high across the world. And this work actually has led to loads of other work, for example, looking at the correlations with socioeconomic status, with pollution. Loads of people have, I guess, have been inspired by this because it's a really, really ambitious project. And the authors in this NAIC paper also looked at the correlation with safety across New York and getting like census statistics on safety. So I was lucky enough to get hold of the data, and I wanted to see if I could infer any of the measurement, safety, liveliness, wealth, boring on London. So I built a regression CNN using a 65-5-30 split. I rescaled the data so that it gives you the image and the Q score, which is sort of this ranking score of all of the images. And I've rescaled that to be between 0 and 10. I've also oversampled the distribution where I was finding that in my model, it wasn't doing very well picking up on the ends. It's quite a normal curve. So picking up on the ends of distribution, it wasn't doing so well. And then I also have a learning rate schedule with the initial 0.001 and decay. I used ResNet. I tried a few models, but ResNet has quite low capacity compared to VGG, for example, to regress the Q scores for safety, liveliness, and I reported the test accuracy. And I wanted to see what that looked like in London. So for safety, liveliness, wealth, boring, this is missing here just because I think something went wrong with the output, so I'm sorry about that. But you can see it's actually doing quite a good job at predicting. One of the things which I think is important to point out, for each of these indicators, they have a different number of votes. So for safety, for example, there's 500,000 different votes have happened across these set of images, whereas for boring, there's only been 150,000. And what I noticed is that models with more votes actually have lower error. And there's sort of two ways that I thought this could come from, which one was to say, you know, intrinsically, the image is not very representative of, let's say, beauty, for example. But I think the more reasonable one is to say, given the fewer number of votes, there's actually not a lot of certainty around the ranking scores themselves. So the model's getting a lot of noise in, and as a result, it's putting a lot of noise out. So it's more difficult to capture the mean absolute error, or the mean squared error in this case. So so for safety, for example, a mean squared error of 1.3 is sort of saying, if you predict, you know, if you were to predict cluster, if you were to predict decile for safety 5, it is sort of predicting in plus or minus 1, which is not bad, I would say. Okay, so here's just an example of some of the London images with a high safety, which is on the left, and a low safety, which is on the right. So immediately you can sort of see that greenery is correlated with high safety in this set of images. In the right, there's a lot more brick, a lot more fence, a lot more red as well, typically. So this is just an example, just to illustrate. So one of the things also then I started to think was the place pulse was taken from 162 different cities around the world. And sometimes that might not necessarily reflect what's happening in a given location. So for these set of 6 images, on the green scores are the ground truth as rated by the people that looked at these images. And on the right is the prediction from the model. And I've just looked at images which have a difference of more than 3. So if you were to choose 2 of these images and ask which one is safer, the model will tell you that it's this top middle image, for example, whereas the people actually voted on the bottom right image. So it sort of led me to this question, like, how do people vote contextually in a given area, and is it different based on different demographics of the people, and whether or not they know that urban environment? So I guess people sort of have priors about how to move in certain places, and because I was looking at London, I wanted to have a look, well, what does it mean for the city of London? So I decided that I was going to collect my own data. So I built this very similar to Place Pulse, really with two differences. It's focused on London, and also I've used this pre-processing clustering. I've used the clustering from what I talked about in the first section to show people images stratified by cluster. So essentially it's to say, can we make more efficient the process by which we show images, so not to show people which we think there'll be like an obvious winner. That was actually quite interesting. I did a initial trial with collecting just a small sample of ratings from individuals, trying to test this hypothesis. For the if I was to use images which had high and low Place Pulse inference scores, would there be an obvious winner when it came to the user selecting each of them? And from the pilot that I did, it was shown that actually there wasn't a strong pattern. So sometimes they were choosing low when it was high and vice versa. So I haven't used the Place Pulse scores to stratify the images as they're shown. I've just used the clusters and clusters alone. So I've used this framework. I have absolutely no experience developing web apps, so it's complete overkill, but anyway, it works. And you can visit it at pulselondon.co.uk. And there's also, I've done a little blog on how to build sort of this this type of web app where you have like a database in the back. I had to go through ethics to sort of get this up and running. Luckily, I'm not using children in the survey, so it was a lot easier than if I was to be including children. And we did a launch in June where we sort of did a sketching event at the same time with my colleague Aina, who's an excellent sketcher. And then Reach, so I'm lucky to be here, so hopefully all of you can have a look at this website and contribute some of your ratings. It'd be super, super helpful. And I guess sort of the reason is to look at, once we've collected ratings, so the question that I'm asking is, which street would you prefer to walk on? And I was interested in this because when the lockdown happened, I sort of learned a new way of navigating my local environment, where it was, okay, you have to just figure out where to go, where to walk, where to just get a break within your immediate vicinity. And sometimes those routes would be really wonderful, and sometimes it was not so great if you're switching it up often. So the question essentially is asking where people would prefer to walk. And I think from this, if I can build a model which can infer across the whole of London, then it's to say, well, which sort of areas are I don't want to use the word pit, it sounds a bit negative, are zones of low walkability where people actually are not interested in visiting, and could those sort of be given as proposal for urban renewal? So this is an example of the app. So you get this question, on which street would you prefer to walk? And you can choose. Sometimes the image isn't shown because Google changes the database every now and again, which is a nightmare, but it's manageable. And it will also tell you, well, was this in agreement with the Place Pulse ratings? And I've just used two, which is safety and liveliness, which I thought, first of all, have a low error and also could correlate to walkability. And it will tell you as you go along, as you click on each of these, if you think if it is or is not matching the Place Pulse ratings. Okay, I'll take a pause then maybe and just look at questions, because for the last two slides, it's just a little bit small, literally 2 slides on the 2 other projects, which were part of the Pathways project. Okay.
I guess, would you be open to people just asking questions now, and then once they're done, then you can then do the last 2 slides, like in terms of people can unmute themselves and ask you questions?
Oh yeah, sure, that sounds good.
Okay, I think we had a question from Hercules. If you can unmute yourself and ask the question. Oh, okay. While waiting for that, we've got Olukbenga. You can you can unmute and ask the question.
Hi, Emily. Hi, everyone.
Hi.
Yeah, just a quick one. The first few slides you showed, it seems to me that what you're trying to do is like a sort of transfer learning. Am I correct?
With the first few, I guess I am using transfer learning because the RMAC model is being pre-trained on ImageNet, yes.
Yeah, so what I'm trying to, I just want to suggest something like, sometimes just from my own experience, when you're doing like domain to domain, if the domains are not closely related, you could actually have problems with your predictions, yeah? So, yeah, because you were saying something about the cluster 8 and all that. So it could be noise. Yeah, so it could be noise actually. So yeah, so that's the first one. Then the second one is like, I'm really interested in getting in touch with you because I'm currently doing my master's at WITS and I'm working with remote sensing.
Yeah.
So yeah, which is closely related to what you're doing. And the problem I'm having right now is I don't want to use unsupervised learning, but I'm trying to see a way I can automate labeling. So I don't know if you have any experience in that. Yeah.
So I've got, on the first point, yeah, it's a great point, and I guess maybe some of the models which are looking at adding a cluster label loss sort of start to address this, because not only are you extracting the feature based, but you're also training the entire model for this cluster label loss. And then the next set of models, which is this generative models, would also be looking at reconstruction. So you're sort of fine tuning the network to also reconstruct your original data set. So it would be interesting to see with comparing the different models if there's a way of, if they're actually leading to different results, because they sort of now work around this source and target data set. And then in the second part, yeah, definitely. So my colleague Barbara actually is doing unsupervised clustering for satellite imagery. And so she's the expert in this. And I'll be super, super happy to put you in touch so you can talk. And her and I have been drawing a lot of inspiration from one another in terms of methods, even though we have different data sets. But I think it's a very exciting place to be. So yeah, really happy to be in touch.
Thank you.
Okay, cool. Raiseche, you wanna come on?
Hey, awesome work. I'm quite curious. Have you explored like adding auxiliary labels, such as like maybe data from like other overlays or like spatial overlays or surveys or things like that to sort of reinforce the current data set as you're doing unsupervised sort of learning and just comparing the experiments?
Yeah, good question. So the only way that I'm sort of using these auxiliary labels is how to like post hoc for interpreting to see what are the correlations. So I've sort of avoided using them within the clustering itself to maybe address this sort of thing that I've mentioned earlier, which is, you know, if data is available and abundant, and how can it be used to measure and understand the environment at high spatial and temporal scales? What is the case when you don't have auxiliary labels? Can you still use the same methods to address something like that? So I've only been thinking of it post hoc, and I think one of the difficult thing with the point level images is that it's really difficult to get point level labels for an image, unless it's usually this sort of aggregate thing where it's, you know, related to the spatial area, but you know, 100, it will include like 100 or 200 images. I think that's one of the challenging things.
Another question I actually had was around, have you tried using models which were pre-trained on other Street View images rather than ImageNet?
So for the clustering, no, only for the segmentation and segmentation object detection, because the TensorFlow Deep Lab uses cityscapes for pre-training to get those features out. But I actually haven't used for the feature extraction for clustering. I haven't used other models which might use Street View images. If you know some that exist, but now that also the previous question, it made me think if I could use Ezra's previous work to which is predicting socioeconomic status from the images as a sort of backbone. It just came to mind.
Yeah, Timnit's work also did, she made models for the US though, but then perhaps she might have pre-trained models.
But Timnit was super different, right? Because she had to extract first the cars and then build this entire new classification and like understanding of types of cars. And then the final one was the logistic regression for predicting the different economic statuses and stuff. So I think for the extracting, I mean, that's another interesting thing is around her work is, is it different types of cars? Like, does that translate even to London in the same way that it would in the US?
Yeah, I suppose the similarity would be that it uses, I mean, ImageNet is like, I don't know, images of, like the scene is a little bit different from just how Street View images are sort of structured, just the images themselves, not even the context of what people are interested in. But then I don't know, I tried using models which were pre-trained on satellite images to do other satellite imagery work for transfer learning. And I get interesting results. Sometimes they work, sometimes they don't. But I was quite interested in if Street View also has sort of these inconsistencies.
Yeah, I think that could also be tested quite easily. I like it. Just doing the VGG, predicting on some cityscapes type data and seeing if it changes or improves the clusters afterwards.
That's quite awesome work you're doing.
Thank you. It's nice to see you. Nice to hear you.
Okay, we have a question from, sorry, I don't have the name, it's iPhone at the moment. And then Hercules, you can ask your question next. iPhone says, I wonder with few features and low accuracy, is it possible that some sort of bias has crept into the cross-validation of the random forest model? Is it possible to find out how this happened, if it happened, and rectify to improve the model accuracy and correct them if they're wrong about this point?
Okay. I'm not sure if bias would have crept in. It could just be that it's just not, those are not enough features to accurately describe the clusters. And I suppose what you're then asking is, are there local patterns in the feature which are descriptive of the cluster, or do you need to include the global image to actually have a holistic view? So I suppose in a perfect world where objects perfectly describe clusters, we would see really good accuracy. So I think rather than it being biased, it's sort of maybe saying, well, there's something else in the image that's not just objects and it's not just segmentation, but it's this sort of more general view, and let's call it the entire gist of the image. And it could be, one of the findings from my colleague was for predicting air pollution with Street View images was that at certain sites, temporally, it would be good at predicting using end-to-end, but not using features, which would be objects, because actually the color, so like the intensity of red, was more predictive than any particular object in the image, which I thought was super interesting. So I don't know if I'd call it bias. I'd just say maybe it offers a new avenue to explore, well, what else is in the image that is interesting? And maybe one of the ways of thinking about that would be to look at activation maps. And unfortunately, in the RMAC method, that's not possible, but in the in the deep cluster method, that could be possible to say, okay, well, what else is in the image that is leading to this cluster assignment?
So thank you for that again. There was a question from Hercules. He can't switch on his microphone, but on his side, I think it was a question about the visualizations. I think I was going to bring up the same thing.
Oh yeah.
Yeah, they're very tough to read at the moment. And most likely, so he says the visualizations from different classifications look complex to interpret. Are there other ways to ways to visualize this data in a way that can make understanding of the classifications in terms of London easy to understand from somebody who's not an expert in this specific problem? Because I think, again, from an InfoVis perspective, it takes a while in those slides. Sorry, I'm adding my own screen here. It takes a while to really interpret what it is actually going on in those slides.
I mean, there definitely is. This is just the way that I've come up with so far, and it's developed through the stages. I think one of the things that I really have enjoyed about this work is QGIS, which is the first time I've really used it since starting. And I think maybe I could find room to explore sort of map visualization. I bumped into something called Kepler recently, which I've never used before, which looks quite interesting. And also like the interactivity of it, now that I'm a web developer. Maybe that's something I could also look at.
All right, thank you. If there's, okay, whoa, more questions. So you can also raise your hand if you want to actually say out your question. But we have from Hazem, have you looked at integrating LiDAR data and satellite data?
You know what, I would actually love to do that because we have access to it, but I don't know if it will fit into the timeline of the research that I'm doing, if I'm honest with you. Ezra did look at integrating it using, so she's got a paper out from, I think this year, using Street View and satellite to predict socioeconomic variables. I don't think there was a huge improvement in accuracy.
Okay. All right, and then I think there was another one from research. Accuracy, is accuracy a representative metric really for this work?
So maybe this is a little bit similar to the previous question from, I've forgotten, sorry, which was, is there any bias in this model? But I guess it's more of a heuristic for getting closer to an understanding of how to interpret clusters. I don't think, I mean, if it was 100% accurate, then it might be interesting to know that cars, for example, are 100% predictive of what the cluster is, and then you might just say, well, these clusters are really boring, actually, like I didn't need to know that. And then you might also just say, I don't need to do clustering because I already have methods to extract features. So maybe the fact that it's not 100% accurate is a little bit more interesting of, well, what are these clusters detecting? And I think maybe if you recall some of the visualizations, typically it's not these really, like, for example, with the terraced residential and the high density estate, it's not really things which are easy to capture with objects being detected, but they have semantic meaning for us when we're exploring the neighborhood, like if we see these different types of built environment.
Thank you. Are there any questions? This has been very interesting. Sorry, I guess maybe a D-side question. What are the kind of bad things people can do with this data, these kind of methodologies?
What are the bad things people can? I mean, the thing with Street View is that there's not a lot of sources of imagery with Street View. We've got Google, we've got Mapillary, and typically there's a cost barrier behind them. So once you circumnavigate, if that's the right word, the cost barrier of Google, and you have access to all of these images, you could do bad research, whatever. You could say how many people of this community live in this area and how can you relate it to whatever, some certain statistic. Hopefully that wouldn't make any peer review as you went along. Obviously, I think we've all seen examples where stuff like that can, but I think hopefully there's a high enough barrier into collecting the data for you to feel like the research like that would be meaningful, maybe. That would be my hope, but who knows?
Yeah, just a quick one. I know you have the 2 slides and we're about to close off.
No worries.
I'll try to keep to the time. So maybe it'd be good to do your slides. And if we can squeeze in that one more question, I think Raisaja wants to ask one more, but let's do your 2 slides and then. Yeah. Okay,
there were only really, okay, so the transferability project, which is how I initially began in the Pathways project, was looking at, do poverty and wealth look the same the world over? So a comparative study of 12 cities from 5 high-income countries. And the idea here was to collect both imagery and census variables for, let's say, income, and look at, well, what happens if you train in London and predict in London, which is these 2 mapped here. How does it look if you train in Toronto and predict in London, or train in New York, or train in Los Angeles? And this work was led by Ezra, who's a research fellow at the Pathways. And essentially what was found was that wealthier neighborhoods look more alike than poorer neighborhoods across these 5 different cities. And there's loads of different sort of interpretations to do with migration patterns, sort of just planning and development in different cities and different countries, how that changes. For example, in the US, things are more transferable within the US than outside, and the same was true of Vancouver. So there's sort of national policies as well. So that was one of the projects. And then the other project was looking at basically how can we detect objects from street view images in Accra. And so Sierra, who's a fellow colleague, she's done what would be called a measurement campaign in Accra to collect pollution, levels of pollution at sensors, so air pollution, noise pollution, in collaboration with Raphael Aku. And along with that, it was imagery. And we essentially had to localize objects that could be meaningful, so stuff like a loudspeaker, a stove, and together with Ricky, we came up with this means of creating a small labeled data set using this label box tool to be able to actually identify these things in a new context, which is unseen before, and then sort of look at the distribution over the city. And Ricky and another colleague, Vish, are continuing this project into look actually predicting now sources of air and noise pollution, which I thought might be interesting because I saw that a talk previously this month was looking at a similar thing of noise pollution in, I think it was Uganda, if I'm not mistaken. So if that person happens to be on the call, they might be interested. And then that's it. And please visit my website.
Okay, I did put the website in. Can you stop sharing the screen?
Yeah, sure.
Cool. Thanks, everyone. I don't know, Raisaja, if we can do that question. You might have to just do it just because of time. Thanks, everyone, for participating. And also thanks to Emily for giving some time to make this presentation. It was very interesting. And I think, yes, it falls within exactly what this seminar is about, looking at the data science in society and really some of these things that pop up. It is not just technical problems that we deal with in this work, but we're dealing with people, we're dealing with understanding of not just ourselves, but also policymakers who will make decisions by some of these kind of things. The next talk is on October 15th, and that will be Timnit Gebru, who will be joining us. It will be an afternoon talk, and it will be in collaboration with the Masakani research project. And it will most likely take the form of a talk/workshop on there. So look out for the email just with announcing it formally, and then you will be able to RSVP. I have also put a link to our news or blog that has all the videos of the previous seminar, so you can actually check out all of those. So thank you for coming in. Hope you enjoyed your the morning. And for those who are at University of Pretoria, enjoy your wellness days and apparently get off all of your devices and enjoy the spring day on there. Thanks again, and yeah, see you next time.
Thanks for having me.
Thanks, Emily, and yeah, have a good day.